and I will share my screen. And just to let everybody know, I have kind of a migraine tonight, so I'm going to do my best to get everyone's questions answered, but in case I'm a little slower than normal, that's the reason why. So we're talking tonight about classes and modules. What are classes? A class is a grouping. It is a specific way to group data and functionality all in one. And you can set it to a variable and you can pass it around. The nice thing about objects is it's a handy container, and you get to define the container. You get to say what's in the container and what happens in the container. A lot of languages like Java are wholly object-oriented, which means everything exists in a class. Everything, from the main method to every last function, exists in one class or another. Now, Python, we haven't gone down that route because Python allows for procedural programming as well as object-oriented programming. Well, what's procedural programming? Up till now, everything we've done has been procedural programming. You don't have to group data and functions. You can just create them in a script and run the script. Object-oriented is a bit different because you can't just create the script and run the script. You have to create structure around what you're doing. So there's this idea of something called a class. And a class is the definition for object-oriented program. It's the major thing that you have. And a class has a keyword called class. That's what it is. It's all lowercase, it's class, and it tells Python, I am about to kind of create this grouping of data and functionality. Just like when you have the def keyword, DEF, before you start defining a function, or as the first thing you do when you define a function, the same thing happens for class. When you use the class keyword, Python is expecting a very specific syntax. Inside a class, you can have what they call a set of variables. And these are, a set of attributes. Attributes are basically variables that exist only inside the class. And they're there to contain information that you're going to want to use later. You can have a class with anything. You can have a class with the word time in it. You can have a class for a rectangle. You can have a class for a car. So anything that you can define that is a grouping of data and functions can be defined as a class. If we think about our projects from last week, or that were turned in this week, you can define a room as a class. And a room would have an item that needs to be picked up, and it would have the directions that you could go from this room, and it would have the functions to move to the next room based on what data was in the class. So there's all kinds of things you can define a class for. In here, at 8.2.1, they talk about the class for time. So you're creating the class time. Now we'll talk a little bit more about this here, but classes have specific nomenclature. They have specific syntax. So what we see here is we see the class keyword. We see the name of the class next. Okay? So, please excuse the yawn. And in this case, the word is time. So the name of the class is time. And then you have a colon, which tells Python that the class block is about to begin. And then you can have a comment. This is just a multi-line comment. Then you can do lots of different things. You can define variables. You can define functions. What they're showing here is a very special function, which is called a constructor. Okay? The constructor is called whenever you create an object from a class. So what's an object? An object is an instance of a class. A class is only the definition. Okay, that's all you're doing is defining something. You're never populating a class with data. You're never calling a function on a class. You can usually only call a function on an object. So when I say an object is an instantiation of a class, you can think of it as the difference between a float variable. Well, you can think of it as the difference between the definition of a string and the string itself. So Python, we have strings. Those strings are immutable. And string is a type. And we get things by defining or by Python recognizing that something is a string. So the same happens with a class. When Python realizes you have defined a variable as a class, it knows what's happening based on the class that you've defined it. It's kind of like we're defining our own types in JavaScript, or sorry, in Java. Sorry, I've been writing Java for the last 3 days. Well, let me start that sentence again. It's kind of like we're defining our own types in Python. So, when you create an instance of a class, which is an object, some things are going to happen, and that's kind of what I want you to look at here. In fact, let me just kind of create it. So I'm just going to do new Python file. I'm just going to call it square, if I can type. Actually, I'm going to call it rectangle. Okay, so I've defined this thing called rectangle, and I'm going to add a configuration, Python. Hello, there's rectangle. Interpreter. We don't have an interpreter. Okay. No, we don't have an interpreter yet. Oh, what is that? That's not. I know. There we go. Python interpreter. Okay. So, I'm going to define a class. Yeah. Okay, there it goes. There we go. Okay. So, I am now going to define a class called rectangle. I'm going to say class. So far, so good. Whoops, except I can't spell tonight. You can barely see. Class rectangle. So what does a rectangle have? Okay. A rectangle has a length and a width. And then what we can do is we can define self and let's say length equals, actually this is going to be len width and we're also going to give these defaults because this is one of those places where I think defaults is very handy because, whoops, WID. So I'm going to use what we learned in functions about having defaults for a parameter, and I'm going to set that here. And what that means is that when I create a new rectangle, if I don't pass in a length or I don't pass in a width, I get 0. And it just makes it a little more functional. And I am going to step size with a self, and that self is very important, and I'm going to return a length. Self.length, self.width. And then, here's more of the magic. I'm going to create square is new rectangle 2, 2. And then, whoops, I didn't do that right. R-E-C-T-A-N. That's much better. Wait a minute, I'm programming Java. I'm sorry, I got that wrong. No new. Ignore the new. I was really sad. I was programming in Java yesterday, and I kept writing a for loop, and I couldn't figure out why the syntax was wrong, and then I finally looked, and it was like, that's because I'm writing Python syntax in Java. So I've just created a square, and I'm going to print, actually I'm going to say area. I'm going to print So I'm just going to run this and see what happens. But if we go through this for a second, I have defined right here a class. I know what's inside my class and outside my class because of the indentation. Okay? Everything from line 11 to line 3 is indented at least one, under the class statement. So line 3 through line 11 are inside my rectangle class. And in fact, I could move this to a separate Python module and then import that module here, and I'd still be able to use the rectangle. And we'll talk about that in a little bit. And now what I'm doing here, what I'm doing on line 14 is I'm creating an instance of the rectangle class with certain values. And I am setting that instance, that object, made from the rectangle class to a variable called square. And then anything I want to do based on that rectangle class that I created, I can do using the variable square. So let's run this in the debugger for a second, and let's look at what happens. So I'm here at square. I'm on line 14. I'm going to not step over, but I'm going to step in, okay? Because right here on line 14, I am about to step into the rectangle class. So notice I'm not up here at line 3, I'm down at line 7. And that's because when I create something of type rectangle, the first thing Python does is it says, go into the constructor so you can tell me what to do. So in this case, and if I look here at the debug information over to the right, I have self main rectangle object, and this is just the memory address of the object when you see the 0x7f. And then I have len and width, 2 times 2. So what happens? Well, if I go look at the debugger, I can look and see there's len 2 and width 2, but if I look down here inside the self, and the self is a special keyword that is used only for classes, I can see that length and width is 0. And what's going to happen on line 7 and 8 is that I'm going to set length to the value of len and width to the value of width. And now when I step over this, if I look here at rectangle, this rectangle has a memory address. And, oh, what did I do? I didn't do that right. Because that didn't set it. I'm going to take off the defaults because I obviously don't know what I'm doing right now. So let's do this again. Just going to leave those defaults off for now. And we're going to do this one more time. Okay. Oh, wait a minute. That was it. The thing that you have to worry about with classes is that you have to be careful and use this self attribute correctly, and I wasn't. Again, because I'm programming in the wrong language in my head right now. Let's try this again and see if I get it to work. So I'm going to step in. I have length of 2 and width of 2. So as I step over this and I look at rectangle, so length is 2 and width is 2. So if I go into the object that is rectangle, I have a length of 2 and a width of 2. I'm going to print the area, and the area should come out as 4, and I need to have a space there. So that is what a square is. Now let's see if I wanted to do a rectangle. So in this case, I'm going to say rectangle. I'm going to say 10 and 15. And here I'm going to say, so what have I done? The only thing I've done at this point is I've added a new object called rect. I'm using the same rectangle class, but I'm giving it 2 separate values. And given that I'm giving it 2 separate values, I'm going to get a different answer than what is here in square. So let me debug this again. Okay, so I already knew what happened in square. So now I have this square based on the rectangle class. I can look down here in my debugger and I see that length and width is 2 and 2. So if I calculate the area based on the square, I'm going to get an area of 4. So now let me continue on, and I have I'm going to create another rectangle. So I'm going to step in here. Now you'll notice this time that the length is 10 and the width is 15. I'm going to have length for the rectangle is going to be 10. And you'll also notice that this is changed. Okay? If I look here at the debugger and I look at this one, oh no, that's the one I'm in because that's where I'm at. Sorry. So if I look now, square is 0x7fe. So let me step over. So rectangle is created. Rectangle has a separate address. 0x7fe17. Okay, sorry, I didn't go far enough. Square, you'll see it gets here and it's 453. Rectangle, you'll see the memory address starts here at 448. That's because there are 2 separate things in the memory of the Python script. So they are 2 distinct entities. Square is not the same as rect. So if I go and I step over, I will see that the area of, rect. And you can do, let me just run that. Yeah. And I can do copy and paste errors. So that's a simple rectangle class. Okay. what we just showed you is you can have multiple instances. You can have multiple objects created from the same class. We just did it with square. We had one that was 2 by 2 and one that was 10 by 15. Okay. Instance methods. A function is defined with a class. A function is defined inside of a class is known as an instance method. So if we go back to our square, the area is an instance method. And okay, so I just put some comments in there. So this is an instance method, and it's called an instance method because it is a function defined inside the class. Okay, and you can add as many methods to a class as you like. You simply can. You can add whatever it is that needs to be added to solve the problem. I try and factor out my classes when I'm writing scripts so that they have only the functions that are associated with the values or the processing that I want to do. I don't just use a class as a place to kind of dump functions that might or might not be useful. I'm pretty strict when it comes to that. So they're talking here about class objects and instance object. So the class object, it says act as a factory that creates instance objects. When created by the class object, an instance object is instantiated. Okay, so the instance, we already talked about this a little bit. So we have these instance objects which are defined with self dot. And a class attribute is defined outside. So, and my bad. So let me get rid of these because these are just redundant. Those aren't right. So let me run this and we're fine. I had class objects defined with the same value as the instance objects because I'm not programming in the right language in my head. So we have self.length and self.width, which are the instance. And then I could have a counter here because maybe I want to know how many rectangles I have. And every time let's see, and then counter, unresolved counter. I'll learn how to spell one day. So let's say every time I create an instance of the rectangle class, I want to keep a count because I want to know how many I have. So what I did was I added a class variable called counter. Now you'll notice down here I'm not referencing that with the self. Self is used only when you have created an object. So that is an instance variable. Length and width are instance variables because they're preceded by self. Counter is not an instance. It's a class variable. So it exists outside of a created object. So its memory space is a little different. And what you can do is you can use it for something like, and having a counter of rectangles doesn't make a whole lot of sense. But if you're thinking of counting, let's say, running threads of a program. So you have a program, it spawned X number of threads. You want to make sure it doesn't ever spawn more than 10 threads. This is what you would do. Okay, you would have a class variable that would keep that. Now, what's important about a class variable is it doesn't change based on what's happening with the object. It's changed only by what's happening when you call the class itself. So I'm going to say print So if I run this, I'm going to say the number of rectangles is 2. Now let's say I add another rectangle. I'm going to call this 2, and I'm going to change this to 100, and I'm going to call this 2. I'm going to call this 2. Now you'll notice I didn't do anything up here. Okay, I didn't add another counter. The only thing I'm doing is I am, in fact, creating another instance of rectangle. But what you will see in the class variable counter is that I have now 3 because counter was changed here. And because it's a class variable, you have to reference it by the name of the class. And I hope that's more clear than mud right now. So we talked about that. So this is just their class example of a seat reservation system. So they have a seat, they have, they have the name of the class, they have the initialization, which is first name, last name, and paid. They have reserve, which can reserve the seat. They have make empty, which can say somebody's really not sitting there. They, say, is it empty? And then they print the seat information. So those are what's inside the class definition. So outside the class definition, we will see other functions. These 2 functions are outside of the class. So they're not something that will be referenced by the object name or by the name of the class. And in this case, I can make all the seats empty. I can also print all the seats. Now, one thing this is explaining, it's talking about, but it's not being really explicit, is you can have a list of classes. You can have a dictionary that has classes in it. So they are treated like any other variable from the perspective of you can put them in collections. They are not treated like any other variable because they actually contain other data. So in this case, we have the available seats, and we have our little reservation loop here. So we go into a while statement, and it allows you to reserve a seat, unreserve a seat, and it's all done with object-oriented programming because it is using the seats that are being created. So, and those seats, like make seats empty, takes a variable seats, and seats is, where is make seats empty called? There's the available seats. Where's make? I don't see where make seats empty is called. Anyway, these take lists of seats. That's what those are. So basically what they're doing here that is not necessarily explicit, but they're creating seats right there, okay? Before we get into the while loop, it comes into this for loop. It takes the available seat collection, which is empty, and it populates it with some number of seat objects, and in this case, it's going to be 5. So those objects will exist, and when you're going through the while loop, it will allow you to modify the objects stored in that list. So, class constructors. We talked a little bit about this before, but a class constructor can have parameters. Now, if you have a class, it at minimum has to have the self as the first parameter. What does this mean? Does this mean you have to pass in a self? No, you do not have to pass in a self. Self exists in the class and the instructor as the object that you are creating. I know that seems a little weird, but that's exactly what happens. So that is the object that is being created. That's what self stands for. And it's not something that you have to pass in, but it is a concept that you have to understand so that you can use classes. After self, which always has to be the first parameter, you can add as many parameters as you like. Now, you should only have as many parameters as you're going to either create for instance variables or that you're going to use for calculations inside the constructor itself. So you don't want to junk up the constructor with a lot of extra stuff. You want to keep it lean. And here they're using the concept of race time, and you have the start time, the end time, and the distance. So here is an example of the race time class. So what we see here is we have the self keyword, and then we have 1, 2, 3, 4, 5 input parameters. And those input parameters all correspond to an instance member of the class, so an instance variable that will be stored in the race time, in the object created from the race time class. We have print time. So, and by the way, all instance methods take self as the first argument. And again, you don't have to pass in self. Python takes care of self. You just have to make sure to remember that you have put it in the definition. So we're going to print the time for self. What does that mean? That means that when you're using the object notation and you do, let's say, Lisa dot print time, it's going to use the Lisa object, or it's going to use the gold medal runner object, and then you can print the pace. So those are the you can create. You can create an object from this. You can print the time for any person that you've kept the time for, and you can print the pace for any person that you've kept that time for. And here we have just some input statements. And then what they're going to do is they're going to create an object called race time. And it's going to be created from the race time class. And you're going to populate it with the start hours, the start minutes, the end hours, the end minutes, and the distance. And as with all other functions in Python, the arguments are positional. So start hours here is, in this case, the second parameter, not the first parameter, for the init method. Because self has to be the first, and this can be a little confusing to people, but you can effectively, once you have written the word self and put a comma after it, you can forget about it. It just has to be there. So that's a little different than normal functions because positional starts at the left position. With the init method, positional starts at the second to the left. So it doesn't start with self, it starts at the next parameter to the right of self. And if anybody has any questions, please let me know. You can have default parameters in a constructor, which I was trying to do earlier and again wasn't programming in the right language in my head. So in this case, we have an employee class, and we have wage equals 8.25 and hours equal 20. 8.25 and 20 are default values. So if you don't get any, if they don't put wage in there, if they don't put hours in there, that's what you're going to get. You're going to get a wage of 8.25 and hours of 20. Now you can put a different wage in there. You can put different hours in there. And then the values will be different for that. But you don't have to if you have a default. Let's keep going. Let's see. Defining a class constructor. So we'll walk through this a little bit. I promise. I know I've kept us over a lot lately. We will end at 10 tonight. Write a constructor with parameters self, num-mins, num-messages, num-mins, and num-messages. Num-mins and num-messages should have a default value of 0. So let's just do this, and we'll create the default constructor. Because that's all it wants you to do here. You don't have to write the remainder of the class. So I'm going to do, this is, what is this? This is 8.61. Python file. Okay. So here we have to fix something that exists. There we go. Sorry about that. And all they want us to do is write a constructor. So the constructor is very easy. The constructor has a very specific syntax. Def, underscore, underscore, init, underscore, underscore. Let's start there. Okay? So that's the beginning. It's not the end, it's the beginning. And then what do I want to do? Well, I'm going to take two variables, okay? When I look over here, it says with parameters self, num-mins, and num-messages, okay? So let's do this. Copy and paste. So these are instance variables, so it's going to be self, num-mins, and self num-messages. And here I'm going to have num-mins and num-messages. And I'm going to set this equal to num-mins. I'm going to set this equal to num-messages. Now, is that everything they want from us? I don't think so. Because they also said they want a default, num-mins and num-messages should have a default value of 0. So I'm going to do that. I'm going to make the default value here 0. And I do that by, in the parameter, in the function definition, I set the value. So now let's see what happens. I'm just going to run this, and what is it looking for? Is it waiting for an input? Yeah. Okay, I just put 100 in for everything. So That worked. So let's see what values they put in. They put in my plan 200, 300. Dad's plan is going to be 0 and 0. Mom's plan is going to be 500 and 0. So let's run this one more time. So my plan is going to be, what is it, 200 and 300. Dad's plan is going to be 0 and 0. And Mom's plan is going to be 500. And that's what we get. So all we had to do is write this constructor to match what it is they wanted. So, whoops, did I miss a comment? I did not miss a comment. Okay, nothing in the chat. Like this. So, class interfaces. A class interface is basically just a set of method definitions. So it contains a class interface consists of the method that a programmer calls to create, modify, or access a class instance. So basically, all they're saying here is that the interface is the function definitions. Now, it is different in Python than it is in other languages. When you're talking about Java and an interface, you are actually defining something called an interface as opposed to a class. Here it's more of a conceptual thing because the interface is in fact the functions that you create. And why is that important? That's important because when you're out in the programming world, somebody is going to rely on those function calls. And if you go around changing those function calls, it's going to make things more difficult for the people who are using the code. I almost never am the only person using my code. My code is often written to interface with other people's code. So if I have a clear definition of the functions that happen in a class, it makes it easier for everyone. And that's really what interface is standing for here. It is the definition of how you use the class as opposed to the implementation of what happens in the class. So that is what they're really talking here about an interface. Talking about abstract data types, which we're not worried about. Class customization. What is this? Okay, so these are some pretty interesting things you can do when you define a class. In this case, what they're talking about, and they're introducing this concept to you using a special class called underscore underscore stir underscore underscore. And what stir does is basically it says if I'm going to take an object created from this class, what happens if I use it in place of a string? For example, in a print statement. Well, let's see what would happen first if I didn't have that. So I'm just going to copy this. I'm just going to call it truck. Okay. So let's change this to truck. So I'm, for the time being, going to comment this guy out. Just comment it all the way out. Okay. So if I have this, the only thing I've done is comment that stir out, and I run it, this is what I get when I print truck. Does that tell you much? Sorry, when I print toy. Sorry, I don't know why I named this truck. When I print toy, that's what I get. Tells you nothing about the toy except where it sits in memory, because that's the memory address that Python uses for where it stores this particular object. So how do I make it meaningful if I want to print the toy? Well, I define the underscore underscore string method. And that method is a special method, and it tells Python when I'm using an object created from the toy class as a string, this is what you do. And in this case, this is what it's going to do. So if I run this again, you will see Monster Truck XX costs only $14.99, not for children under 5. How did that get there? Well, it got there by using this, because Python is assuming anything in a print statement is a string, and it's going to automatically attempt to convert any non-string to a string so it can print it out. In lack of anything better to do, it's going to give you the memory address of that object. But we can give it something better to do, and that's by using this particular method. And there are several of these types of methods in Python. And we just saw that. Operator overloading. So we know what operators are. We've been using operators all term. There's a way to overload an operator so that you can compare classes. So maybe I want to know if, in this case, it's the less than, or maybe I want to know if two classes are equal, or maybe I want to know if two classes are greater than, whatever we determine greater than to be, because as the creator of your classes, you're in fact creating what that means. In this case that we see in front of us, we have this underscore underscore LT underscore underscore class name. It is a special class name, just like underscore underscore stir underscore underscore. And yes, the double underscores are important. It is saying when I am evaluating two classes, create two objects created by the same class with the less than sign, I am going to call this method. So let's see how that works. I'm just going to copy this right now, and we're going to call this time. Okay, so here's time. So let's take a look at what we're doing, because I think some of this might be clearer if we step through in the debugger. Let's edit the configuration. Let's go to time. So let's debug this, because I want to kind of show you that it's clear. So first of all, I don't start my program up here. It starts down here. This is the first line that is going to execute inside the Python call. So if I start stepping over, I have this, I've created an array called time, and then I'm going to enter the time, hours, minutes. So I'm going to go to console. I'm going to enter the time, hour, minute. So I'm going to say hour 2, minute 2, and then I'm going to keep going, and then I'm going to do it again. Num times is 3, so I'm going to say 3, colon 3. I'm going to do it one more time. Whoops. I didn't do it right. Okay. That would be why. So let's do this again. You can't see anything, Kat? Kate? Can anybody else see my screen? Okay, I'm assuming, okay, so other people can see my screen. Kate, this is being recorded, so if you can't see the screen now, you should be able to see it on the YouTube recording, which will be up tomorrow. Huh. You just see the black screen. I can stop sharing really quick, and then we'll try it again. Oh, okay. If you're okay with just seeing it tomorrow on YouTube, that's fine. I will send out a link to all the professors tomorrow and an announcement to my class. So we're here. I'm just going to put another breakpoint there so that I can continue. And so I'm going to be here. I'm going to go to the console. I'm going to put in :2. Whoa. Let me do this right. :2. I'm going to do, okay, 3:3. And I'm going to do one more. I'm just going to say 4:4. Okay? Hit the enter key. So now let's see what's going to happen. Okay. Now, one thing that I didn't mention when I was doing the other ones is the time object is being created on line 24. And what's happening here is it's creating a time object, giving you the input from the tokens. So basically it's splitting them up. And it's converting them to integer, and then passing them in to create the time object. And it'll be calling the init function when it does that. So when I step over this line, or actually let me step into, when I step into that line, it's calling the time constructor. You'll see hours and minutes. In this case, it's 4 and 4 because that was the last input I gave it. And it's going to set them, and it's going to come back out. It's going to go to the top of the loop and say we don't have any more to do. So now it's going to try and figure out what the minimum time is. So it says for t in time, so that's all we're doing here. T is an object of type time. And it's going to say if t, which is time, less than min time, then set min time to t. Let's see what happens when I step into this less than. So we don't think about less than as being called as a function, but because we have defined this __LT__, Python's going to use that. This is not a normal LT because we've defined it in the class where these objects came from. So I'm going to step in, and lo and behold, I go to line 10, which is __LT__. And what we're going to do is we have defined, or this program has defined, what it means to be less than. So if the hours associated with this particular object are less than the hours associated with the other object that we put in, so when we're doing this, if we look here, T is self, okay, because it was on the left-hand side of the less than statement. The other is min time, okay, this is the other object. Because it is on the right-hand side of that statement, it's going to be here at other. So it's going to basically say if self.hours is less than other hours, which it's not, then don't return true. Let's look at it again. If self.hours is the same as other.hours, then it's going to look and say, what about the minutes? Well, it's the minutes, so we return false. Because we return false, we don't walk into line 29, and we check it again. And we walk in, and here we are in the LT again. This is special, remember. It's because we defined this inside the class that these objects were created from. And I'm just going to run it, and we will see that the earliest time is 2:2. So that's what's important here, is that we were to be able to define our own less than operator. You didn't see an underscore underscore LT underscore underscore called anywhere in this code, but you didn't have to, because that's the equivalent, because I defined the class, I defined the operator. And there are all kinds of operators, and here they are, okay? Less than, greater than, less than or equal, greater than or equal, equal, and not equal. You can define one of these, comparison, create your own operator, and if you put in, a not equal, it will go to this function that you defined in the class. So that's what they mean by operator overloading. You can create your own operator-based evaluations. And it might read a little funny to you because we're used to calling things by their function names. But these are special, and they're only available if you define a class. Okie dokie. This is just defining the stir, and we saw it in the other one. It's the same thing. All you're going to define is an underscore underscore stir and print it out. And I promise, okay, that we will be done soon. So here's a lab for car value, and you're just going to create a class. In fact, they give you most of the class for the car value. And what do they want you to do? All right, complete the car class by creating an attribute purchase price, which is an int, and the method print info that prints the car's information. If that is it, then it's basically just going to format what the car's information is. So that you only have to do two things here. Okay, you have to define a print info class, and you have to have an instance type of purchase price. The instance type of purchase price is going to go right here. You just have to have the self dot syntax. And then here, you're going to define a print info, and the print info is just going to be printing this stuff out that looks like this. And then it will call it. So those are the only two things you have to do. You're not having to define the class yourself. So if you are comfortable writing a function and you're comfortable creating an instance value and you practice using the self, you'll be just fine on this one. Okay, winning team. So this is your just get win percentage. So you're just defining a function to get the win percentage here, and that's about it. You're not having to define the whole class by yourself. You're only having to deal with the get win percentage. You're going to have this particular calculation in there, and understand that when you are in this class, you're going to have to be dealing with instance attributes. So that means you're going to use self. So instead of team underscore wins, you're going to have self dot team underscore wins divided by paren self dot team underscore wins plus self dot losses, self dot team underscore losses, close parenthesis. So that's what you have to understand here, and that's the purpose of this. You are dealing with an instance, So you have to make sure you're using that self value correctly. When in doubt, put self in front of it. Okay, modules. What's a module? Well, we've been using modules all term. We just haven't known it. A module is, in fact, a collection of code. That's what it is. It is a collection of code that you can import into your program that gives you functionality. If you're dealing with regular expressions, you would import RE. If you're dealing, I was dealing with, what was it? I was dealing with Watson, IBM's Watson, which, by the way, is pretty neat if you ever want to do text to voice. They have their own Python module, so I imported their Python module to get all of the functionality associated with Watson. All I had to do was connect and build a program around how to connect to Watson and how to send information to Watson. But that's what a module is. It is a grouping of like functionality that you can use. Python has lots of modules, all kinds of modules. You have math modules, you have astronomy modules, you have modules for game programming. So, but that's all that a module is. It is it's a collection of functionality, and you bring it in using a special keyword called import. Import says, Python, bring in this module. Now, on different systems, you have to manage the modules differently. I'm on Linux. I deal with pip install, which will install a module for me and make it available to the Python interpreter. Here it has an example of HTTP server. If you are trying to access a web interface from your Python code, this is very reasonable. You don't want to go out and write low-level communication stuff. Somebody has already done that. And what you can do is use what that somebody has already done and bring it into your program. And there are so many open source modules. The first thing I do when I'm writing a new Python program that may potentially have new functionality that I haven't written before, I go out and look and see what's in there in the open source community. I just do. And then I find out whether or not we can use it. What's the licensing associated with it, all of the businessy stuff that we have to figure out. And what I often figure out is, yes, we can use it. If it's open source or it's under the appropriate licensing, the company will say yes, because it saves so much time to bring in a module and use that module than try and write low-level system calls. So that's what a module is. It's a grouping of functionality. You can bring in that functionality and use it in your Python, and it makes life so much easier. How do you find modules? Well, Python has a lot of built-in modules, but you can go out searching on the web, okay? And there's this nice little utility called pip, which is the Python, I can't remember what pip stands for, but it is basically the thing that will go out and install a module and let your Python instance know where in the world it was put, so it knows to go get it. So how do you reference something that you get it from a module? Well, you can import the whole module, and then you can access it based on that module name. Or you can say, maybe I don't want everything, because what happens when you import is you're physically pulling code into your running Python. And sometimes that's a lot of code, and you're only going to use a little bit. So there is the concept of only importing a part of the module, the part that you want to use. So the syntax for that is a little different. Instead of just import, the name of the module, you can say from the module name, import, maybe you only want a specific subset of functionality, and that subset of functionality is named. So you just import that. So you tell it what module it's coming from, and then then only the stuff that you want to import. This is important because it will reduce the footprint of your running Python. And that means your Python code will be smaller. It will take up less memory. And if you're running a really, really, really big Python module, you want to clean out as much stuff that you're not using as you possibly can. So this becomes a very easy way to reduce code bloat. And code bloat is a thing to reduce code bloat. So let's see. And you'll use modules all the time when you're programming in Python. Executing modules as scripts. Yeah, it's just, it's very much the same thing. You're just using them inside your script. It's really all you're doing. Those are nice little modules, packages. So they're saying a package is a directory that, when imported, gives access to all the modules stored in the directory. Large projects are often organized using packages to group related modules. So this is just a way of grouping modules together. And that's great. I don't know anybody who uses packages. Not even IBM Watson used packages. You just use a pip installer, and it installs the module, and then you call the module. So I almost never I don't think I've ever really dealt with the concept of a package, not in real life, in Python. Standard library. So Python gives you a lot of stuff in what they call the standard library. And we used random, we've used time, there's math, there's OS, there's sys. So this is all just what comes standard with Python. And all of the different stuff that you can use. And you can go out to any one of these pages and take a look. You don't have to import these modules, or you don't have to install these modules separately. They come with Python, and they're very handy to have. Numpy. So this is just talking about, it says Numpy, the package Numpy provides tools for scientific and mathematical computations in Python. You can perform linear algebra with it. And I think what they're really just trying to do here is they're trying to use an example. And they're saying import Numpy as NP. So when you want to access something in Numpy, rather than saying Numpy dot, you're going to say NP dot. So I think that's really all they're trying to say there. And then this is the last lab. And it's optional, so you guys don't have to worry about it, and we won't necessarily have to go through it. So, nutritional information classes and constructors. Okay, so it's optional too. You guys don't need to worry about that, and I think all the rest of this stuff is optional. Yeah, this is all optional. So, does anybody have any questions before I sign off with this group for IT140 for the last time? I'm going to take that as a no. So I'm going to stop sharing my screen. I'm going to stop the recording, and I hope this was helpful. I will have this up sometime tomorrow, and I will send out, for my class, there'll be an announcement, and for everybody else's class, I'll send the information to the instructors. Good luck, and I hope that you all have a wonderful time programming in Python.